Today on Inevitable, our guest is Jason Marks, co-founder and CEO at TELO. TELO is developing EV pickup trucks in the footprint of a Mini Cooper, with a bed the size of a Toyota Tacoma and the power of a mainstream truck. They're focused on urban use cases for pickup trucks, whether that be a weekend adventurer who lives in a city or an organization whose employees need trucks for work in urban environments but are fed up with navigating giant vehicles through traffic, parking, and underground lots. I was interested to hear Jason's take on why he thinks now is a good time to build a clean sheet EV from the ground up, why he thinks what they're building with TELO will have a significant market, and why it's not one that existing truck manufacturers have gone after, and also why today's pickup trucks are so giant in the first place. MCJ is thrilled to be an investor in TELO via our venture capital fund, where we back founders like Jason who are rewriting industries to be cleaner, more profitable, and more resilient. From MCJ, I'm Cody Sims, and this is Inevitable. Climate change is inevitable. It's already here. But so are the solutions shaping our future. Join us every week to learn from experts and entrepreneurs about the transition of energy and industry. Jason, welcome to the show.
Thanks for having me. Excited to be here.
Well, I am excited to hear what you're building with TELO, and I want to start right there. What does TELO mean?
So TELO is short for the Greek word telos, T-E-L-O-S. Aristotle talked about this a lot. It actually means purpose. So he talks about doing things for a purpose, the greater purpose in life. And we're building pickup trucks for the city. We're building trucks in general for the downtown cities for a purpose.
So leaning in with trucks for a purpose, what I assume all trucks are for is driving with a purpose, but you have a very clear mandate in line for why someone would ultimately buy your truck, which we're going to come to. I want to spend a bunch of time on that. But before I do, I want to understand your background and how in the world this became the thing you wanted to spend your time doing.
I've always been those kids obsessed with automotive since they were the youngest of toddlers. Used to dress up as Henry Ford in Halloween in elementary school. But I built my first vehicle from scratch when I was 13 years old, and I crashed into a blaze of glory in my high school parking lot. Not learning my lesson, I did that all over a second time and built a crazy big contraption of vehicle again that crashed into my high school parking lot. So I realized I got to go learn how to build a safe vehicle. And when I went to Columbia for mechanical engineering, I came out and was like, all right, I want to focus on vehicle safety. So I started my career working on actually the components that went into autonomous driving. I worked on LiDAR and radar semiconductor, and then worked my way into working on the software systems that were working on ADAS and autonomy. I ended up developing the ADAS safety systems for a bunch of major automakers, including the first two electric pickup trucks in this space. Early on in that career, too, I was introduced to Forrest, and it was funny because we were just having a general conversation with a few mutual friends.
Forrest is now your CTO and co-founder.
Forrest is now my CTO and co-founder, yeah. I met Forrest, and we realized that we both had pole vaulted at the same high school in Washington State, which is just such a bizarre set of circumstances to meet up. And if you know pole vaulters, you know we're all the same crazy in our heads. You can even see my pole vaulting picture behind me. It's a big part of who I was. The whole motto, run fast, jump high, that pole vaulters have. I like to live my life by that. So Forrest and I hit it off. Forrest was actually working in city transportation as well. He was thinking about micromobility and how we can fix the problem about how there's so many cars on the road. Forrest has a really interesting background, though. He was on the Stanford Solar Car team back in the 90s with J.B. Strobel that turned into the early days of Tesla. So he was in that early days of Tesla. He built the battery packs for the first Roadsters. He left, started Mission Motors, which is one of the first electric motorcycle companies in the Bay Area, and broke the land speed record for an electric motorcycle. So raced it out of the man, had an amazing time. He left there and actually started PlugShare, which is a company that some of your audience may be aware of. It was the #1 app for finding EV charging stations. Flores has such a background in battery technology and electrification. I had this background in safety and certification, and we realized that we have this perfect mesh to go after a problem in this space where we both can tackle.
And you decided to go after this space of purpose-built pickup trucks for the urban environment. Describe what that is. What is TELO?
Well, we started with electric mini trucks. So we're building crew cab pickup trucks with the same capabilities as an F-150, the range of a Tesla, but in the footprint of a two-door Mini Cooper. So the length and width of a two-door Mini Cooper. I was actually inspired by my trip to Japan over a decade ago, where they have these little small Japanese K-trucks, they call them. They are 134 inches long, and they can carry as much as a full-size truck can carry in the US. And they're everywhere in downtown cities, and the government incentivizes them in Japan because it makes it more efficient to navigate the downtown city.
Those are ICE vehicles? Those are gas-powered?
These are almost 100% ICE vehicles. Japan hasn't made the transition yet to electrification. They're working on it. But we realized that, man, we should have something that's comparable to this. There should be a way to actually do work in a downtown city. And if you're a weekend warrior, to go out snowboarding and mountain biking, if you live in a downtown city without having to either try to shove a 4x8 sheet of plywood into a Toyota Prius or being unable to park your big truck in a downtown city. So this all started because it's a very selfish endeavor. I have a 150-pound dog. I live in downtown San Francisco. I take him to the beach, but I can never park outside of my favorite restaurant on the weekends. So I just needed something that fit that mold.
Growing up, my dad had a little Mazda pickup truck. It wasn't very big. I didn't live in an urban environment. I lived in Kansas, but it strikes me that those smaller, even at the time, the small Mazda or Toyota trucks aren't really around anymore in the US. It feels like over the last 15 plus years, pickup trucks have gotten huge. Is that sheer observation or is that fact?
You're 100% correct. And you're actually right in the time period too, because there's actually something that did happen in that window. So you're right that the Toyota SR5, the Honda, the Ford Ranger from the 90s and 2000s, those were small vehicles. Those were the same size as today's sedans are. And now the average pickup truck is the size of 3 king-size mattresses stacked end to end, almost 20 feet long. And that all changed over the last 15 years. Actually, it comes down, and I know that the ethos of your guys' podcast is all around climate. And this is a perfect example as how the road to hell was paved on good intentions.
It's a good line in a Sturgill Simpson song, by the way.
Yeah, exactly. The Environmental Protection Agency was actually established in the 1970s. The first thing it was trying to tackle was this gas crisis in the 70s. So it limited fuel consumption in vehicles, but it only applied to passenger vehicles and exempted trucks. So if you built a truck and you were doing work, your truck could burn as much fuel as necessary to do the work you needed to do. In 2010, that all changed. And that's exactly what we're saying 15 years ago. The administration said, we're going to bring in light-duty trucks to the mold. We're going to make sure they meet certain fuel economy requirements. But the way that they got away and said, okay, if you're doing work with a bigger truck, if your truck is bigger, it must be doing more work. So if it's doing more work, it's allowed to burn more fuel per mile driven. So they literally published a chart where the x-axis was the size of the vehicle, the y-axis was the amount of a fuel efficiency that needed to hit in miles per gallon. And as your truck got bigger, you could hit less and less fuel efficiency. So as you imagine the model maker sitting there going, well, it's going to be really expensive to do an entirely new engine program, and it's going to be less performant and everything like that. But if I just stretch my frame by 4 inches, I meet all the requirements. And the thing is, every single year, those requirements get harder and harder to hit. So every single year, the automakers stretch their frames larger and larger and larger and larger till we end up today where the actual line does asymptote, it gets flat after a certain period. Every single automaker sits right where that line gets flat. That's the size of my truck now, and that's the size of 3 king-size mattresses stacked end to end.
So in order to try to drive autos to be more fuel efficient, we, the royal we, in terms of our policy environment in the US, unintentionally created giganto trucks.
Exactly. And the crazy thing is, if you look at the statistics, this decision is actually killing Americans. In the last few years, we're at an all-time high in pedestrian deaths. 7,500 people have been killed on all streets across America. And if you look at how the statistics break down, that's an average of 2 people per 100,000 pedestrians that are killed on streets. There's 21 cities in the US that number is over 50 per 100,000 people that are killed as pedestrians on US streets.
Jason, the way you tell this story, it sounds like the automakers were sitting there doing their thing and these rules dropped down and they're like, oh, I guess we could go this way. I have to imagine in reality, there was some pretty heavy lobbying involved by the legacy automakers to create these carve-outs for trucks. You may not know the answer to that, but boy, the skeptic in me feels like that's probably what happened.
Of course, the answer is yes to that. And there's plenty of examples you can actually see where they spoke in front of Congress at this time. But this isn't the only problem. We're also seeing this push, especially in California, for example. 2030 is 50% of all vehicles are supposed to be electric by that time. Nationally, it's supposed to be 2035. Those numbers will move around. We know that. But if you look at what the trajectory is, all the automakers know that electrification is coming. And the best path that they're thinking to make electrification happen is building these multi-engine platforms. A platform that can do hybrid, it can do gas, it can do electric. And if you do that, what you've effectively done is taken a heavy, big vehicle that you've already created, throw 2,000 to 3,000 pounds of batteries on top of it. And now you've got a 7,000 to 10,000 pound vehicle that's not really solving the problem that it was meant to solve. Because if you look at the amount of energy required to move that 10,000 pound vehicle a mile, and you look at where that energy is coming from, the equivalent miles per gallon for that big vehicle is about equivalent to a fuel efficient small gas sedan. So you see all these competing challenges that are coming about for the size of the vehicle, for electrification, all being driven by the fact that we need to find a way to get these vehicles to market and meet the government requirements.
There are also, I think, tax loopholes for cars being heavier too. If you own your own business, you can get some tax benefit from buying a heavier truck than you can for buying a car.
Absolutely. So there's two different things in that. There's the 6,000 pound weight rating. And what's really important to note about weight ratings for vehicles, there's the curb weight of a vehicle, and then there's the GVWR of a vehicle. So it's really important because you can have a vehicle that weighs 10,000 pounds, but it can only carry 1,000 pounds. And then the GVWR of that vehicle would be 11,000 pounds. You could have a vehicle that weighs 4,000 pounds that can carry 6,000 pounds, and that would have a GVWR of 10,000 pounds. So the GVWR is really what is your vehicle capable of carrying fully loaded. So it's really important in our ethos. We want the lightest weight vehicle possible, but we want to have a heavy enough GVWR so it could carry a lot. And that's the way that you actually benefit from both of those tax benefits. You can say, hey, we're going to meet the requirements for the heavier vehicle, but 99% of the time when you're driving this vehicle, you're going to be a lighter and more efficient vehicle.
Super fascinating. So help me understand, then, there is this wave of pure EV trucks coming. Obviously, I see cyber trucks all over the road now. The Ford F-150 Lightnings are harder to pick out compared to just a regular Ford F-150, but they're there. I've certainly seen them. But these are all monster giant trucks still. Why hasn't the industry, if 15, 20 years ago, people wanted the smaller Ford Ranger and the smaller Toyota truck, why aren't the legacy automakers making EV versions of those?
Well, because they had this platform. They built all this time and energy to build this massive platform that's largely been influenced by this EPA regulation. And it's the easiest thing to do is to throw the 2,000 pounds of battery on top of this platform. A lot of the work has already been done. They don't have to back up and go through an entire vehicle phase from phase one, which is a very difficult thing to do. And us being a small startup, we have to do that. This is by definition. So we're doing it from the ground up. And we're building our vehicle around this use case for the small truck. So we can make decisions that the big automakers haven't made. We can build the most space-efficient battery pack ever created. We can build a safety system that doesn't require a long hood of the vehicle. And we can weave in the electrification components into various different locations in the vehicle to make it all work.
That's true of Ford for sure, but not Tesla. Cybertruck's a clean sheet design, isn't it?
I can't speak for what was going on in the head of the Cybertruck creator, but they ended up where they ended up, and they chose not to go down this route of the city vehicle, maybe largely influenced by their decision to move to Texas. What we've noticed is that there's a lot of people that love their big truck, and we're never going to convince them to move to a small truck. That's totally fine. We don't need to do that. What we need to do is solve the problem around city mobility and on city transportation. The city actually runs on service, maintenance, and utility vehicles. If you drive downtown San Francisco, downtown LA, downtown New York during the week, you'll see it lined with trucks, pickup trucks everywhere. We've talked to a ton of different general contractors, construction, maintenance, utilities, waste, everybody that drives a truck. And they've all got ideas of how they want to make their vehicles more sustainable, but they've also got this problem that they have to park a mile away from their job site every day. They don't have this ability in dense urban environments to actually park right by their job site and get that transaction happening very, very quickly. And even if we move to autonomy and micromobility and public transportation, because the city is densifying at a really, really rapid rate, it doesn't get away from the fact that we'll always have trucks in the city, beverage trucks, maintenance, utilities, waste, those will always exist in the city.
So I'm hearing you say you built this to scratch your own itch, which is you've got a big dog, you live in downtown San Francisco, you want to be able to navigate taking your dog to the beach and still park your car at night. And you've heard and you know that there are also use cases for commercial vehicles that need to have a pickup truck, but also don't want to deal with having to park a large F-150 or whatnot in an urban environment.
Exactly. And it was funny because when we launched our company in June of 2023, we were really in the mindset of consumers, people like us. There's a lot of people that must really, really want to have a small truck because of the utility of it. What we didn't expect was the massive influx we got of commercial and fleet customers reaching out to us directly and saying, hey, this is a problem that we've had for forever. We need to solve this problem. It's getting worse and worse and worse and worse, to the point where I have to go buy a 20-year-old pickup truck to do the job it needs to do. And those 20-year-old pickup trucks, if you look at them on Craigslist now, they're selling for the same MSRP they were 20 years ago because they're so desirable. There's also a lot of people that are buying, especially in city municipalities, they're moving towards what they call neighborhood electric vehicles or low-speed vehicles. You may have seen them before, Polaris Gems. And those are great because they're small.
Mokes, I think that's one of the brands I've seen.
Exactly. And they're fantastic because they're small.
They're like fancy golf carts, is how I think about them.
100%. But they can't go on roads higher than 35 miles an hour. They've never been crash tested. They really aren't a vehicle that's made to do any type of really heavy lifting or long travel or go on the highways. So there's this huge gap. So you'll see people in the San Francisco neighborhood I live in, they have one of those vehicles. And the same person that drives that vehicle also drives an F-150 on the very same day because they have to have that joint use case. I can give you a bunch of other examples. Like we've talked to a lot of agricultural people that maybe make their wine delivery drop-offs to the city. They have big trucks and they have ATVs or UTVs on their wineries because they want ability to actually like navigate the winery in on-off-road scenarios. Those can't go on the road either. And they'll sometimes talk to a state of Montana recently and they import these K trucks because they're so useful for being on the farm and being in the city and going to and from the city, can drive on the roads. And I think that it was one of the states recently we can look this up afterwards, recently reversed their ban on K trucks. This is the number one most imported vehicle from Japan right now is a K truck because they're so useful.
So we talked about why the large automakers so far haven't gone down this path of building a smaller truck EV. If you uncover a market here, what's to prevent them from doing it? What makes it hard to build what you're doing?
Well, you've seen how hard it was to build an electric vehicle company. I mean, I think if you look at the numbers, $300 billion have literally been burned on this transition to electrification in the US. It's crazy. I think there's so much money that has been put into the electrification wave, and a lot of automakers are still struggling to not only electrify, but also go after a new market in an unknown space with unknown technology. That's a huge wall to climb for a traditional automaker. But if we start on the fundamentals and say, hey, we're going to develop the technology that lets us go after this market, the two problems we said is, one is the EPA problem. The second problem is that vehicle safety regulations have changed so dramatically over the last 2 decades that the way that most automakers are solving that is just add bigger and bigger and bigger bumpers to the vehicle. It's exemplified by, if you look at the Mini Cooper growth, it started when it was launched in 2000, it was 143 inches long. This next generation is 153 inches long. This most recent generation changed some design, but it hasn't changed design significantly. It's really added additional crash safety regulation bumpers on top of their platform. So we started from the fundamentals and what is preventing automakers from building smaller vehicles? Well, the powertrain and the emissions. So we solved that through forced innovation in battery technology. The safety, and we solved that through the work I've done with automotive safety and really understanding the fundamentals of how a crash actually works and how regulation actually works. And if you put those things together, then you can rethink the vehicle from the ground up. I like to tell the story that when the automobile was first invented in the 1800s, it was a motor on top of a horse-drawn carriage. It was what we call a one-box solution. They could cram the motor underneath, the horse-drawn carriage was in there, and it was all packaged pretty tightly together. Henry Ford in the early 1900s said, well, that's not a way to actually make mass-scale vehicles, and he created the two-box solution. So they put a motor in front of you, they put the occupancy behind you, and the storage behind you. And that model has existed for over 100 years now. And as we transition into electrification, we don't need to just copy what's been going on for the last 100 years. We just say, what does the world need? And how do we use this new technology to actually address that need?
Let's talk about China. When we think of EVs in the US, we talk about what's Ford doing, what's GM doing, what's Tesla doing, what's going on there. But when you think about EVs across the world, the story starts and almost ends with China, with maybe Tesla as an asterisk. Explain a bit about the China EV phenomenon, and do you view that as eventually something that could compete with what you're trying to build?
Yeah, I think that we have to be eyes wide open when we talk about China. They realized 20 years ago that this was a wave coming, and they invested a lot of government energy and money into addressing this wave. Because of all that funds that went in and all the energy that went into it, they were largely successful in making this transition occur. So they've electrified. They've had full cities where everyone drives electric there. They've government incentives for people to drive electric, government incentives to build electric. They actually build entire cities around the automobile factory where the outside perimeter is tier 3 companies, inner perimeter tier 2, inside of that tier 1, and then the assembly plant happens at the end and the vehicle just drives off.
I actually want to hit on that. For folks who haven't been to China, what Jason is saying is so true. The government sets up innovation zones and intentionally creates cities around these themes. It's like what you think of as like the factory town in the US, but that's literally what it is it's these designed factory towns, essentially.
And then there's just a circle of homes around it. So it's like everyone only has a straight shot to walk to work and right back. And the vehicle starts at the very peripheral when you wake up in the morning and drives out the front door when it's done.
And they're run by the government. So if you need a change in how the stoplight works over here to test some sensor you're doing, you walk down the street and talk to your local minister and say, here's what we need to do to prove that this works. Can you help us make this change to how the city runs?
Yeah. And it's incredible how efficient they've been at actually doing that. Now, I think that there's a lot of government security that comes around this. If the Chinese automakers are extremely blowing up in terms of their capabilities, you're seeing a lot of pushback from European and US governments and saying, well, if China's going to be supplying us our vehicles, that's going to be a really hard thing for us to stomach. So put massive import tariffs. But China will figure out how to get vehicles into the US. It's just an inevitable thing. Whether that's through the Mexican border, which is how a lot of people can build vehicles and assemble vehicles a little bit less expensively than they do in the US. And it's also abides by the US trade regulations, so they can drive them up to the US afterwards. Or if it means that they create a joint venture, which we've seen a lot happening, joint ventures with Ford, joint ventures with Volvo. Polestar is a great example where they joint venture and they spin off a new company and it's got American leadership and they can bring a vehicle into the country. Now, what's important to note is that if you do something like that, you're still beholden to U.S. wages and regulations. So you're not actually create a cheaper vehicle than the U.S. are going to create that vehicle. So I think there's a lot of government story around this, and I don't know all the details of it. And I know that a lot of people are looking at this. But what's important to note is your question was, how is this going to affect us? And if we look at what China does and does really well, is they look at the highly commoditized, high volume products within the US that has an established market, and they make it cheaper. They do it less expensively. So they're going to look at the crossovers, which every single automaker builds a generic blob-shaped crossover.
This would be the Model Y, for example.
Sure. I'm not going to insult the other EV companies, but yes, everyone builds a generic crossover vehicle. They build a sedan. They build a big truck. And so China's going to be able to do that and do that relatively inexpensively. What I don't think we see a lot of times is China make the risk and say, hey, I'm going to come into the US market and at the same time go after a new market that hasn't been established yet. So what our job to do as a company is to get to that market, show that market, serve that market, and get to a high enough volume by the time China realizes, hey, this is something that we could go after.
So speed to market is your answer, I guess, to China. And is China already making inroads in the urban commercial fleet space that you were talking about?
Absolutely. And so is Japan. We're seeing a lot of this happening across the board. But what's important to note is if you go to China or go to Japan or go to South Korea, when I tell them what we're doing, they go, Americans love big trucks. It's never going to work. So it's almost like they believe that's the culture of the US. And until they're proven wrong in that, they're not going to make that decision.
Hey everyone, I'm Yin, a partner at MCJ, here to take a quick minute to tell you about the MCJ Collective membership. Globally, startups are rewriting industries to be cleaner, more profitable, and more secure. And at MCJ, we recognize that a rapidly changing business landscape requires a workforce that can adapt. MCJ Collective is a vetted member network for tech and industry leaders who are building, working for, or advising on solutions that can address the transition of energy and industry. MCJ Collective connects members with one another, with MCJ's portfolio, and our broader network. We do this through a powerful member hub, timely introductions, curated events, and a unique talent matchmaking system and opportunities to learn from peers and podcast guests. We started in 2019 and have grown to thousands of members globally. If you want to learn more, head over to mcj.vc and click the membership tab at the top. Thanks, and enjoy the rest of the show.
Let's talk about the US EV market in particular. Lots of blogs and articles highlighting that we're sort of living through this EV valley of death right now. To me, it feels like we're starting to pull out of that personally. But in the last couple years, Fisker, Lordstown, Proterra had their problems, obviously. Even Nikola, Faraday Future, they're still alive. But what happened with this first wave of companies, sans Tesla and Rivian, and why is now different?
So there's an amazing graveyard of electric vehicle companies. But what's important to note is this isn't the first wave. That was wave 3, if you actually look at it from chronological order. Wave 1 was the early days of GM, the EV1, late 90s. Wave 2, that was the Tesla days. And there's a lot of people that actually followed on after Tesla. You saw there are a lot of companies that were established right at the same time as Tesla. And Tesla is the sole winner of that generation of companies. Wave 3 is the Rivians, the Lucids, the Canoes of the world. And there'll be some winners there for sure, but there's a lot of losers. That's when the most money has been spent on EVs in this last wave. And the story of why that money was burned is actually pretty interesting. People got so much money, they tried to move to high volume production without actually building the fundamentals of the company. So if you can't get to a profitable BOM cost, if you can't get to a manufacturing strategy that's locked in with partners in that space early on, if you can't finish all of your homologation design without having to build hundreds of prototypes and spending hundreds of millions of dollars to do that, then you're not going to actually build a successful company. So that coincided with the market crash we saw. And we saw that, okay, everyone who had burned all this money that didn't have a viable product that had established really large operations, well, they were not able to actually weather that storm. So it's because of those challenges that we actually stand up and we think of ourselves really as that EV4 wave. And there'll be a lot of people in that EV4 wave as well. We think we're fairly early on it, but it's when you take the learnings of what came before and really decide to say, how do we get to profitability early as possible? How do we de-risk all of our technology so we can homologate our vehicle as soon as possible? How do we get our vehicles on the roads with the littlest amount of money spent possible? And how do we establish a vehicle that's actually built for a new market? That's how we look at this problem. And there's really three specific things that is letting us do that. One is the commoditization of EV components. I can go out and buy a motor, an inverter, a BMS that's really just off the shelf. It's incredible how off the shelf. It's like a crate motor these days. You can just get it, you can pop it in, and you can drive your vehicle. Second thing, software has gotten so good. And software, I don't mean on just software that goes in the vehicle, but it's the software to develop and the software to test your vehicle. GM coined the term 100% virtual validation. And that's really where we're marching towards, where you don't have to build all these prototypes, spend all this money on hardware to get a vehicle on the road. We've already crashed our vehicle 100 times virtually. And the third big thing is manufacturing in the US is finally coming around. And that is really, really, really important for anybody building hardware across any startup in the US. Manufacturing has always been thought of as this wall of impossibility because it has to go overseas. You had to establish those relationships. You had to go set up all these things. But the US has really wisened up and said, if we're going to maintain our powerful economy, we need to have manufacturing partners inside of our walls and make sure that we can actually build things efficiently and cost effectively, and that we're sharing resources amongst a lot of different companies in one specific location. So contract manufacturing in the US has finally stood itself up and become a viable way to actually build a vehicle.
Is TELO built in the USA?
Yes, 100%.
I love it. Hopefully you've got big made in the USA flags hanging in the office.
We could do that. That'd be great.
I think you should.
So what's important, though, about how we think about it, how we're different from other people that have used contract manufacturing and commoditized components is that the number one core component of any electric vehicle isn't the motors, it isn't the body, it's the battery. The battery is the electric vehicle. It determines your range, your performance. It determines what your vehicle is capable of doing, your weather, the hot and cold that your vehicle can go through. So the battery is everything. And we build our battery in-house by ourselves. And we have innovations that make our battery pack extremely space efficient. So everything around our battery pack is geared towards space efficiency and for the purpose that our vehicle is going to do. And because we're not trying to do a 0 to 60 in 2 seconds, for example, we don't pull that much current. We don't pull that much heat. We still do 0 to 60 in 4 seconds, which is plenty fast enough. But because of that, we can actually shrink a lot of components in our pack, simplify a lot of the cooling and the electrical connections of our pack, and squeeze that space that the pack takes up.
You said you build it all in-house. Tell me more about that. Explain that.
Yeah, we literally get our cells shipped to us, and we're working through a bunch of different suppliers right now and evaluating the different cells. We do have a supplier for the first batch of vehicles. We get our cells shipped in-house. We have all our equipment actually sitting directly underneath where I'm sitting right now is our entire battery lab and our new product introductory line. So if I catch fire spontaneously during this meeting, you'll know what happened. But we effectively get all of our batteries in-house, and we have a manufacturing line that goes from cell to cell holder to doing every single electrical connection in a single process, which is part of our special IP. All of our thermal attachments in a single process, also part of our special IP, gets packaged into our clamshell and then just mounted up to our vehicle. And it's just that process.
Can you share what chemistries you've chosen to use?
So the first batch of batteries, and we'll talk about this in more depth as we release our battery technology more publicly, but our first batch of our vehicles are all running NMC. Really, what's important to us, though, isn't the chemistry. It's that we're looking at really energy-dense cells. So as different technologies come on market, as long as they fit into the 2170 or even 18650 would work for us. But as long as it fits into the cylindrical battery cell, we can use that technology. So as cells get more energy dense, as cells get different chemistries that go inside of them, it doesn't change our manufacturing process.
How hard has it been to try to make sure that the vehicle qualifies for the different IRA tax incentives around battery chemistries and supply chain?
We're not 100% sure what's going to happen to the IRA over the next few months. So we're holding off on submitting any paperwork on that regard, because we know that the election is going to have an impact on that. Really, the IRA has a couple of things that are really important. It has that you source most of your major components from US and allies, and that your batteries don't come from people that they don't want them coming from. So we're compliant as of right now, and we have strategy to get all of our battery cells sourced from the US eventually. So we should be able to meet those requirements. But there's a lot of other incentives that are on top of just the IRA that people may not know about. Like there's the ACF, I think it's called. That's if your vehicle has over a certain amount of weight rating and it qualifies as a commercial vehicle. If you go electric, you get a huge incentive to do that. So on top of the IRA, there's so many incentives that we're trying to qualify for our customers. So if you're a commercial customer and you want to buy a fleet of these vehicles, maybe our list price is $50,000, but by the time you get all of your incentives, our vehicle's $30,000. And that's the sweet spot we would really like to be in. As we build more and more volume of our vehicles, then we can bring our prices down. We can even get that handed off to our customers as well.
And where are you today in building all this? I know my partner Yin got to visit your office a week or two ago and got to ride in, I guess, the prototype. I've heard the phrase functional skateboard. Explain a little bit about where you are with this thing.
Yeah, Yin came by on Friday, so 1 week ago today, and she got to ride in what we launched with last year. So last year we launched with our drivable skateboard, which is really our test bed of a vehicle. It shows that we can fit our battery pack, our powertrain, our specific people packaged together, but it's got no body of the vehicle, just a roll cage and some janky seatbelts, just make sure it's quasi-safe.
It looked like a dune buggy, or
It's very much a dune buggy.
like a fancy Lego vehicle.
Exactly. And people get in it. It's funny because we want you to feel that it feels like a real vehicle. You're not sitting on top of the vehicle. We specifically didn't do cab over on our vehicle because we felt like that would make people not believe they were inside of a real vehicle. So we wanted you to sit below and behind the front axle, but just barely. We wanted you to feel like you were driving in a comfortable real vehicle, despite the fact that it takes up the footprint of a two-door Mini Cooper. So this was really the showcase that we could build a vehicle. If you were able to look over the railing and down over our side of our offices, you would see we're actually standing up our first 3 vehicles being built right now as we speak. So that's going to be a really fun time. We're actually going to get to a fully complete vehicle coming in early next year. And then the world will get a chance to actually see our vehicle in really city streets.
And you've been taking pre-orders for a while.
We have. And we've been very candid about the process we're at. We've been taking pre-orders. We're at about 3,500 paid pre-orders. And it's a mix actually between consumer and commercial customers. So we've been taking pre-orders, understanding that we're not going to deliver our vehicles until at least the end of 2025. And that'll be a very small run that will scale over time.
We met you, by the way, through one of the investors in our venture fund who is a pre-order customer of TELO.
Yeah, that's true. So when we announced our pre-orders, we opened our Discord channel because we wanted to share with everybody our journey as we're building our electric vehicle. We want to be the most open automaker ever, in direct contrast to other automakers that have said something, closed their doors, and 4 years later came out and said, okay, we finally did it 4 years later. But what we want to do is be very open in our development process and what it takes to be able to bring a vehicle to market. So one of your limited partners saw our vehicle at our June launch, joined our Discord channel, messaged me separately and said, hey, I'm really interested in this. Is there any way that I can throw a few bucks into your company? And we said, we would love for you to be a part of our company, especially as a pre-order customer. And that opened the doors to meet a lot of really great people.
And what are the big milestones you have to get to, I think you said next year, to having fully production prototypes of the vehicle? What do you need to solve for?
I want to make sure that I don't say it will not be a production prototype of our vehicle. It will be an advanced prototype of our vehicle.
I do not know the difference of that.
The battery pack will be production, which is really the main goal of why we're setting up the MPI line downstairs. But there's a lot of stuff that has to happen that will be informed by this version of our vehicle. This is the intermediate step between our dune buggy looking vehicle and a full pre-production vehicle. But it will look and feel the part, but it won't have been gone through homologation yet. And that's the big milestone that a lot of companies have to go through.
Homologation, please describe.
Homologation is the process of the government saying, we allow you to drive your vehicle on public roads. And it really is a multi-step process. We're on step 10 of 50 effectively right now. But really what it is you have to show your vehicle is roadworthy, it is crash-worthy, and will save both occupants and pedestrians, and that you're a legitimate automaker. And each of those pieces have their own set of regulations around them. And you may feel not so great about when you hear me say this, but what's important to note about US automaker regulations is it's all something we call self-certified. And that process really means that the government lays out an encyclopedia worth of regulations to hit. It's your job to fill out the paperwork and say you did it, and then submit that paperwork. The government's not going to go through and make sure that you told the truth in every single bit of that.
That's interesting. That feels like that comes from an artifact of the US auto landscape largely being a bunch of very large companies that are lawsuit averse, as opposed to a bunch of startups that are moving fast and breaking things.
It's very true, but it's important what you brought up there is about the lawsuit side of things. So the reason that it's self-certified is so that the government won't get sued if you get into a crash. The automaker will. So you have to do your due diligence to make sure your vehicle's safe, simply because if somebody gets into a crash and gets hurt or even worse, killed, they're going to come back and say, you built an unsafe vehicle, automaker. And it's your job to say, no, we tested, it was safe.
And so how long does, in your mind, the safety and certification process look to take for you all? This is your bread and butter. This is what you built your career in.
Yeah, it's funny because there's a saying in the traditional automotive world, it takes 18 months and $500 million to go through homologation. But I would flip that on its side. So it takes having the confidence that your vehicle is safe to go through certification, to go through homologation. And that requires you to crash your vehicle in a variety of different ways and make sure that it meets those requirements. Most of the other certifications are check marks in a box. Are your lights in the right place? Are they shining bright enough? Are they positioned? Is your seatbelt in the right place? Can it adjust for the 95 percentile man and the 5 percentile woman? All that's check marks. And as long as you design your vehicle correctly from the get-go, you don't have to redo that part. But the process of actually saying, hey, did you crash your vehicle? Well, that's really hard, actually. Do I have to go build 100 vehicles and crash them in various ways? Well, that's what the automakers have done for years. But nowadays, I can go and I can build my vehicle in a software environment with all the correct materials and all the correct bonding processes and all the correct interfaces to everything. And I can go slam it into a wall. And I can do that overnight 100 different times with 100 different variants of our vehicle and get results back and say, hey, here's what works, here's what doesn't work. Let's make the modifications the next day and let's go crash it again 100 times. And because we have that really quick design cycle and doing all these things, it's brought down the time to homologation to about 12 months, but it's also brought down the cost of homologation to a tenth of what it's cost before. So it's incredible.
Now, anyone who's built software in staging environments knows that once you ship to prod, something's going to be different no matter what. Presumably, you still are going to have to go smash some real vehicles at some point, but it sounds like you're planning that it will be a lot fewer than has been the traditional pathway.
It'll be less than 10, and that's really important. We have examples of this actually working. Koenigsegg, for example, only crashed one vehicle to complete destruction because they have a $3 million vehicle. They only crashed one vehicle to destruction to get their vehicle on the road. And they went through all the process of homologation for the European world, which is actually very similar to the US, just with a couple of big differences.
And then at some point, you're in parallel, I guess, needing to spin up your sales and go-to-market arm for the company. What does that look like? Is this a direct sales model to start? Is it this urban commercial fleet model that you've decided on going to be the sole pathway, or are these going to be showing up in my neighbor's driveway?
So this is actually really important, and it's actually something that we learned relatively recently. And so I want to really point it out. We've spoken to a number of people in this space that were maybe the CFO at a bunch of really big early EV companies and also was the CEO at maybe the credit side of major automakers. And we've learned that if you go with a strictly direct-to-consumer model, you actually run into a couple of major issues. Tesla was able to actually overcome these issues, which is fantastic. But one of the big issues you run into is that if you're manufacturing your vehicle through a third party, through a contract manufacturer, and you're going direct to consumer, you effectively, as an automaker, have to purchase that vehicle outright from that contract manufacturer. As soon as it comes off the line, you own it. And unless you can just quickly turn around and sell it, that's an asset that sits on your books. As that asset stacks up, it becomes a huge liability to your company. All the value that you're creating is now sat in your books as a liability. That's almost an impossible red area to get out of unless you've got a really efficient way to get those in customers' hands. So we realized that, especially for commercial customers.
Just to clarify, this isn't a direct sales model like Tesla. This is why I assume most of the traditional automakers have had the dealership model for years, where they don't actually own the vehicles.
Exactly. And dealers get a lot of flack, but what they do provide is a service that someone can drive up, they can go get their vehicle serviced, they know who to talk to, they've got a person they can call. There's a couple of really great things that a dealership provides. And there's quasi-dealerships out there that service leasing companies, especially in the business world, that do maintenance, servicing, leasing, and everything. And we're in conversations with all of those people right now. So we really want to find the model that works for the most people as quickly as possible. It doesn't require us to have assets that sit on our books for a really long period of time. And the truth of the matter is it's probably going to be slightly different for the consumer base than it's going to be for the commercial base.
So am I hearing you say you expect to have some sort of dealership partnership?
I won't talk too much about the actual specifics of it because it may not be what you would consider a traditional dealer, but it will be someone that can provide a leasing service and maintenance as well to customers as they buy your vehicle.
Got it. And it sounds like that's probably a couple years away. Would that be the right way to think about it?
It's at least 12 months away.
What does this become? No car company offers one SKU. So if you get to market quickly with this and beat China to market or whatever and build your footprint, what do you envision the business being in 10 years, 15 years?
Well, in the future, the cities are going to work, and it's going to be because of TELO. And we see that the city runs on maintenance, service, and utilities across the spectrum of different vehicles, everything from the smallest of vehicles to the largest of vehicles. And we think every single vehicle that exists in that space today is twice as big as it needs to be and uses at least 3 times the energy to do its job than it should be using. So we think that we can solve across that spectrum with our technology and safety and battery applied to the vehicles in different formats. We can totally change the landscape of the city transportation. And that's what we want to do. So that means class 1 vehicles to class 6 vehicles, we think should all have the TELO ethos in them.
So any vehicle that is having to navigate an urban operating environment is fair game for you to think about as a potential market expansion pathway.
Exactly. With the same ethos of how do we build the most space-efficient vehicle possible that's extremely efficient to drive.
and talk about how you've capitalized the company to date. Obviously, as I've mentioned, MCJ is a happy investor in what you're building, but describe a little bit more about how else you've raised some money.
So what's important to note is that we want to be the most cost-effective automaker ever. So how do we get to market? How do we get to vehicles in customers' hands with the least amount of money spent possible? So when we actually raised our previous round, we had built a functional vehicle spending just over $1 million in its entirety and developed a battery technology and a safety technology to do so. We just closed a roughly $6 million seed round that was led by NIO. So if you guys know, Ali Partovi runs NIO, and he's one of prolific investors in the Silicon Valley. And it was followed on by a couple of major investors as well, including Sparrow. To note, one of their main investors that did the deal was Mark Tarpenning. Mark Tarpenning is the original founder of Tesla. So the original founder of Tesla wrote off and said, I'm really excited about this. I'm ready to go do it again. Let's have some fun. And funny story is that we share a backyard with that original building in San Carlos from Tesla. So it's all in the same Tesla little mafia. Martin Eberhard, the other founder of Tesla, also invested as well. We got investment from MCJ, of course, which we're super excited about because we think that climate is a huge part of why we're doing this. And then we got investment from Andy Palmer, who is the ex-COO of Nissan. He launched the Nissan Leaf and is called the Godfather of EVs because of that. But he also was the CEO of Aston Martin. So we have this amazing set of automakers and people that have been in the automotive space that look at us and say, hey, I really like this direction you're going. I'm not put off by the fact that EV 3.0 wave had come and gone and left this graveyard of electric vehicle companies. I think this is unique and differentiated that we're going to back it and support it. So that's where we're at right now. We're not raising at the time being until we showcase our next generation of vehicles. But we're super excited in the beginning of next year to really show the world what we've been heads down working on for the last 12 months.
Where do you need help right now?
Well, right now, if you're interested, if you're a B2B customer and you have a fleet, I'd love to talk to you. So you can reach directly out to us. I'd love for you guys to all follow us along and be involved in our company and tell the world that we're trying to be the most open and cost-effective automaker ever. What's really important is that we get a lot of inbound for people, and you guys have helped us with this a lot, but we get a lot of inbound for people that are really interested in joining our company. And I wanted to say, we're always interested in having those conversations, even if we're not hiring at this given point. And if it's something you're interested in doing, reach out to us on LinkedIn. We'd love to have a chat. And even if it's not a role we're filling right now, we could put it in the pipeline for a later time. That's it.
What's been surprising to you so far in building this company? Any assumptions you had going into it that you have found were false?
A lot of things are surprising. Every single day, we have a new surprise that hits us pretty hard. It's always surprising how Mark Tarpenning has a really amazing statement in this. He says, it takes 4,000 parts to build a vehicle, but only one part not to. And it's so crazy how much investment goes into the pieces that you may not think of as the big investment pieces. Like headlights is a huge program usually. Seats are a huge program usually. But you would think, hey, the structure of the vehicle, the suspension kinematics of the vehicle, that's all really hard engineering. That's not where a lot of the time and energy ends up being taken. It's on the small parts. Seats are not a small part, but the small parts, the bits and bobs that really add up.
Yeah, getting the final fit and finish. You're talking about safety being so important. Obviously, figuring out the seat construct would presumably be a big part of that.
Yeah, I'll say this is probably the number one thing that struck us by surprise. And we've been warned about this and we didn't listen. Now we're very aware of it. Building a beautiful body of a vehicle is quite the difficult endeavor. And it's not just difficult because you need really nice surfacing and there's all this how light reflects, but it's how you actually construct a vehicle body. A vehicle body has an exterior surface. It has a structure that goes inside of that surface. If it has a closure panel, it has interior of that surface that closes it out. And that's all melted together in much different ways. And then on the interior side of the vehicle, there's those three stages as well. So in order to build a vehicle body, a top hat, if you will, there's 6 different layers that go into it. Exterior structure, interior of that, and the entire panel of that, exterior structure, interior of that. And then there's a floor. And so it ends up, there's so much stack up of different things that need to be engineered and designed and work within the space you're creating that if you don't know how to do that, you're not going to be able to build a vehicle. And we've heard of stories of about EV companies struggling with this over the last 10 years because they realize hey, I know electrification, I know mechanical engineering, but they don't know that. So what was really important is that we actually were contracting with a particular individual who was considered to be the foremost expert in this and did a lot of the early vehicles in this space. And when we got through the first stage of it, he called us on the phone one time and was like, look, guys, I think you've got a lot ahead of you, but I love your project and I really want to be a part of it. And I think that you're actually going to make a big difference in the automotive space. So bring me on board. I want to be involved full time. Let's just do it. And we're like, hell yeah, let's do that. So we brought Dale Beaver on board and his expertise in actually making sure we're staying focused on actually delivering a vehicle has been crucial. And I don't think we would have succeeded as a company without him.
What else should we have covered, Jason, that we didn't talk about?
There's a fun fact for you. If you took every single vehicle that's currently registered on streets in America and butted them all up side to side and front to back, it would cover the entire landmass of New York City, Los Angeles, and Seattle put together. That's how big our vehicles are today.
What do you want that footprint to look like in the future?
Half the size.
There we go.
Exactly.
Awesome. Well, Jason, thanks for joining. Loved catching up as always. Loved learning more about what you're building. And hopefully we've inspired some folks listening to rethink how they think about the future of automotives in the US and maybe beyond.
Awesome. Thank you so much, Cody. Talk to you soon.
Inevitable is an MCJ podcast. At MCJ, we back founders driving the transition of energy and industry and solving the inevitable impacts of climate change. If you'd like to learn more about MCJ, visit us at mcj.vc and subscribe to our weekly newsletter at newsletter.mcj.vc. Thanks, and see you next episode.